Welcome back, everybody. Today's deep dive is all about the microservice chassis pattern. Um, Building microservices can be a real pain sometimes. Like all that setup for each one, security logging, and just all those little configuration things.
Yeah, it's true. I mean, you could end up spending like a whole day or two just
Yeah.
on the groundwork before you even write like a single line of code that makes the service unique.
Exactly. And that's where this chassis pattern comes in. It's like having a pre-built foundation for all your microservices, like a blueprint, so you don't have to keep reinventing the wheel.
Yeah, think of it like building a car. You wouldn't build a car from scratch every time, right?
Right.
You'd start with a chassis that already has all the core components in place. And that's basically what the microservice chassis is for software.
Okay, that makes sense.
Yeah.
So what exactly is included in this chassis? Like what kind of stuff is pre-built?
Well, one of the key parts is the reusable build logic. This means you have standardized processes for building, testing, and packaging your microservices, often using tools like Docker. And this saves you from writing those same build scripts over and over again.
Got it. So it's about efficiency and consistency. But what about things like security and logging? Don't those need to be handled for each service individually?
Well, that's where the chassis pattern really shines.
Yeah.
Instead of configuring security separately for every microservice, the chassis can have those measures built in.
So it's like a built-in security system for all your microservices.
Exactly. And the same goes for logging and monitoring. The chassis standardizes how these are implemented across all your services. This gives you like a unified view of what's going on in your entire system. And that makes debugging and troubleshooting way easier.
That makes a lot of sense. Having that consistency across all your services has got to be super valuable.
Oh, absolutely. Another important element is externalized configuration. This lets you change settings for your microservices really easily without redeploying them every single time.
Oh, yeah. I've seen configurations become a real headache in microservices projects. So having that centralized management sounds like a big help.
It definitely is, and there's more. The chassis pattern also takes care of service registration and discovery.
Right. Because in a microservices environment, those services need to be able to find each other and communicate, like a directory service or something.
Yeah, exactly. And the chassis handles this for you. It automatically registers new services and makes them discoverable by other services in the system.
Wow, so it's like a built-in GPS system for your microservices.
That's a great analogy. This simplifies inter-service communication and makes the whole architecture more robust. But wait, there's more. The chassis can also incorporate patterns like circuit breakers to make your services more resilient.
Circuit breakers, I've heard of those. But can you remind me how they work?
Sure, imagine one of your services starts having problems. Without a circuit breaker, a cascade of failures could take down your whole system. A circuit breaker acts like a safety switch. It isolates the faulty service and prevents the problem from spreading to other parts of your application.
So it's like preventing a small electrical short from causing a major power outage.
Exactly. It's all about building fault tolerance into your architecture. And the chassis pattern gives you a good way to do that.
Okay, this is starting to make a lot of sense. Consistent build processes, security logging, configuration management, service discovery, and even fault tolerance. It sounds like the chassis pattern does a lot.
It does, and we've really only scratched the surface here. Yeah, there's a lot more we can talk about with this microservice chassis pattern. One thing I find really interesting is how it simplifies development with this thing called a service template.
Oh yeah, the service template. We mentioned that earlier. Can you tell me more about what that is and how it works?
Sure, so think of the service template as like a prefabricated structure built on top of that chassis we talked about, like, having a blueprint for a house.
Okay.
You don't have to design every single room yourself from scratch.
Right.
So instead of starting from nothing every time,
Developers can get a head start with a working example. That already has all the best practices and configurations from the chassis.
exactly. The service template usually includes basic stuff, like handling HTTP requests, connecting to a database, or interacting with the message queue.
So it's like having the foundation walls and roof already built,
Yeah.
and you just need to add the furniture.
Yeah, exactly. Developers can take this template and customize it to what their specific service needs, and they can get started right away. They can focus on the unique business logic without getting bogged down in all the infrastructure stuff.
That sounds super efficient. What are some of the practical benefits of using a service template like that?
Well, one of the biggest benefits is consistency. Since all your microservices are built on the same foundation, they all share the same structure and follow the same standards.
Right, that makes sense. That would make things easier to manage in the long run.
For sure. Imagine trying to maintain a bunch of vehicles. where each one was built from scratch with completely different parts, it would be total chaos.
Yeah, that wouldn't work very well.
Yeah.
So having that standardized template would be a big relief for development teams.
It definitely is. And don't forget about updates. When you need to make changes or apply security patches, you only have to update the service template and the chassis, and all your services get those changes automatically.
So it's like having a central control system that pushes updates to all your microservices at once.
Exactly. And that saves a ton of time and effort for maintenance and upgrades. Developers can focus on building new things and delivering value to users,
Oh,
instead of getting stuck doing tedious updates.
this all sounds amazing. But are there any risks or downsides to using this pattern?
That's a good question. It's always smart to look at both sides. One thing to think about is vendor lock-in. If you choose a chassis that's too tied to a specific language or framework, it might limit your options for using new technologies in the future.
So it's like building your house on a foundation that only works with one type of material. Switching to something else later could be a real pain.
Yeah, that's a good way to put it. That's why it's important to choose a chassis that's both feature-rich and flexible, something that can handle what you need now, but also lets you adapt to new technologies as they come along.
That makes sense. It's finding that balance between standardization and being able to adapt.
Exactly. Now let's talk about some actual frameworks that can help you implement this chassis pattern. For Java developers, Spring Boot and Spring Cloud are great options.
Oh yeah, Spring. That's huge in the Java world. What makes them so good for this pattern?
Well, Spring Boot is known for being easy to use, and it lets you create standalone, production-ready Spring applications really quickly, with very little configuration. And then Spring Cloud builds on top of Spring Boot. It gives you a whole set of tools specifically for building and deploying microservices.
So Spring Cloud is like a collection of pre-built components that fit into the chassis pattern, handling things like service discovery, configuration management, and circuit breaking.
Exactly. It's a whole ecosystem for developing and managing microservices using Java.
That's great for Java developers. What about other programming languages, though? Are there frameworks available for them, too?
Of course. For Go developers, there are some popular choices like Gizmo Micro and GoKit. Each framework has its own features and benefits.
So it sounds like no matter what language you're using, there's probably a framework out there to help you implement the microservice chassis pattern.
That's right. The important thing is to figure out what your specific needs are. Weigh the pros and cons of each framework, and choose the one that best fits your project goals.
Okay, so we've talked a lot about this microservice chassis pattern. All the benefits like consistent builds, security logging, configuration management, service discovery, even fault tolerance. It seems like a really powerful way to simplify and standardize microservices development.
Yeah, definitely. But there's one more thing I want to bring up before we finish. This idea of finding the right balance between standardization and flexibility.
Oh yeah, that's a good point.
Where?
We talked earlier about vendor lock-in. Like if you choose a chassis that's too tied to a specific technology, how can developers make sure they're getting the benefits of a chassis, but still have the flexibility to adapt to new things in the future?
That's a great question, and it's something every team should really think about. One way is to design the chassis with a modular architecture, so you can swap out or upgrade different components as needed.
So like building a house with interchangeable parts?
Yeah.
If you want a different roof later on, you can just swap it out without having to rebuild the whole house.
Exactly. That kind of modularity makes your system more future-proof. You can adapt to new technologies and changing business needs.
That makes a lot of sense. But being modular can also make things more complex. How can developers make sure their chassis stays manageable, even if it have a modular design?
Well, that's where good design principles come in. And really understanding the boundaries within your system. It's important to have clear interfaces between the modules to make sure they can work together smoothly, but still maintain some independence.
So it's about building a system where all the parts work together, even if they come from different places or are updated separately.
Exactly. It's about finding that sweet spot between structure and flexibility.
This has been a really insightful discussion about the microservice chassis pattern. I'm sure our listeners are going to want to learn more
Yeah.
about how to use it in their own project.
Yeah.
Do you have any final advice for them?
Yeah, I would say start by really looking at your current development process. Figure out where the pain points are. Are you spending way too much time on configuration? Are you having trouble keeping things consistent across your microservices? Once you know where a chassis could really help, you can start looking at different frameworks and tools that fit with your technology and what you're trying to achieve.
That's great advice. Don't just jump into a new pattern without understanding what problems you're trying to solve.
Right, and remember, there are a lot of resources available online. documentation tutorials, open source projects. Don't be afraid to try things out, learn from what others have done, and adapt the chassis pattern to your specific needs.
That's a great point. Well, I think that's a good place to wrap up our deep dive into the microservice chassis pattern. It's been a fascinating conversation, and I hope everyone listening has learned something valuable about how this pattern can make their microservices development a lot smoother.
I agree. It's a really exciting area of software architecture, and I encourage everyone to keep exploring what's possible.
That's all for today, everyone. Thanks for joining us.